Hi, my name is Emma. I'm a developer advocate for Google Cloud. Today, I'd like to introduce OpenSaves, an open source cloud native storage for game development. Many of today's games are rich and immersive worlds. They engage the audience in ways that make a gamer part of a continuing storyline, which means many games have a lot of data from small structured data to large blob objects. And they also need to store each player's progress in cloud. To create these persistent experiences, games face storage and database challenges in order to scale to gamers' expectations and standards. That means game developers need to be an expert in each storage system. And we need to control cost. We need to keep different storage systems and technologies, both high performing and scalable, available to meet the gamers' needs. And those systems tend to be complex. And I think it'd be nice to have a single unified API to provide all the needs for game development. Not only do developers need to store different types of data, they must keep the system performant, scalable, and cost effective. That means we need a single unified interface for all operations, and we offer a well-defined gRPC endpoint. And we optimize data placements based on data size, access frequency, and performance hints. So you only need to use this single API for all operations. And by having a single endpoint means we have reduced operational toil and we achieve greater simplicity, greater scalability, greater cost efficiency, and greater availability based on these best practices. Today, I'm introducing OpenSaves. OpenSaves is a brand new purpose-built storage interface for multiple storage backends. Developer teams can store data without having to make technical decision making on which storage solution to use. For example, OpenShift combines cloud storage, memory store, and file store, and automatically chooses the best place to store a particular data. And we developed OpenSaves in partnership with 2K Games, so we made sure that each API meets game developers' needs. With OpenSaves, game developers can run a cloud-native game storage system built on three design principles. The first one is simplicity. OpenSaves uses a single, unified, well-defined gRPC endpoint for all operations to store metadata, structured and unstructured data. The second one is speed. It's fast. With a built-in caching system, OpenSaves optimizes data placements based on access frequency and data size. And we achieve both low latency for smaller binary objects and high throughput for large blob objects. The third one is scalability. API servers can run on GK, Google Kubernetes Engine, or Cloud Run, meaning it scales out to handle hundreds of thousands of requests per second. OpenSaves stores data in Firestore and cloud storage and can handle hundreds of gigabytes of data and up to hundreds millions of requests per second. Here's what it looks like under the hood. There are three primary components in the backend. The first one is cache store for most frequently accessed smaller data. And the second one is structured store. Structure store. This is a persistent store for structured data, and this is also the default store for any data that's smaller than 64 kilobytes. The third one is bulk store. This is the place, OpenSave stores anything that's bigger than 64 kilobytes. And you can run a load balancer in front of the Cloud Run or Kubernetes open Kubernetes, so you can distribute requests to multiple instances of OpenSaves. And OpenSaves uses Cloud Memory Store, Data Store or File Store in Data Store mode, and Cloud Storage for each purpose. This is what happens when you save something to OpenSaves. First, the client or the game servers send data to OpenSaves. And OpenSaves automatically writes the data to the cache for future references. And at the same time, it writes to the cloud storage, so cloud storage for bigger data, and cloud data store for smaller objects, and also structured data and metadata. And when you load something from OpenSaves, again, the game server sends the request to the OpenSaves, and the OpenSaves checks memory store uh, to see if something is cached there. And if the cache is available, OpenSaves just returns the data from memory store to the client. And if OpenShift cannot find the data in memory store, it sends a request to data store to check the metadata and smaller objects. If any big objects are associated with the metadata, then send the request to the backend blob storage and fetch the data and return the client. As you see, for both store and load, the game client just needs to send a request to OpenSaves, and OpenSaves handles the rest. Here's some common use cases we have in mind. The first one is leaderboard. A lot of games have some kind of leaderboard, both online and offline, and we offer both structured and unstructured data support. For example, leaderboards have some kind of numbers such as levels, time, and score, and we offer basic arithmetic functions to manage data. And leaderboards often have some kind of replay data or user generated content, and we offer metadata and bulk storage to store those kind of data. The second one is game state saves. A lot of games have some kind of parameters and states, and we offer both structured and unstructured support to store data. And sometimes games have bigger data such as assets and patches, and OpenSaves offer streaming API to store up to 100 gigabytes of data. And the third one is player metadata. In-game, players have metadata such as levels, items, and achievements, and OpenSaves provides structured metadata support for those kind of operations. This is a comment from the Vice President of IT and Security, Joe Gaffoler of 2K Games. OpenSaves demonstrates our commitment to partnering with top developers on gaming solutions that require a combination of deep industry expertise and Google scale. We look forward to continued collaboration with Google Cloud. We continue to develop OpenSaves with 2K. So why use Google Cloud and OpenSaves? We offer the simple unified storage API for all operations. That means simple, uh, easy access, and reduce operational cost. And you can take advantage of Google's highly scalable managed services such as memory store, data store, and cloud storage. And Google Cloud has presence in different regions, and you can run and store data in different locations to satisfy user needs. Here are some next steps. Join us on GitHub if you are interested in looking at the source code, contribute patches or file issues. And there is an install and deploy user guide if you want to get started with open saves. There is a development guide and contribute guideline. So make sure to check these if you're interested in contributing to open saves. If you want to learn more about the API, we have the API reference. And lastly, we have a mailing address for our team. So if you have any questions or just want to reach out, uh, we have an address for that. That's it from me. Thank you very much.